5D1, we will solve GATE 2011 Aerospace Engineering question number 38. An aircraft is performing a coordinated turn maneuver at a bend angle of 30 degrees and forward speed of 100 meter per second. Assume G equal to 9.81 meter per second square. The load factor and turn radius respectively are often A 2 by root 3 and 1.76 km, often B root 3 and 17.6 km, often C 2 and 0.18 km, often D 2 upon root 3 and 17.6 km. This problem is related to the turning flight, and you can refer to this NPTEL video for more to know more about it. First, we will see what is a turning flight. Turning flight requires the banking of the aircraft. So, if aircraft is banked at an angle phi, and for this turning flight, thrust, velocity vector, lift and drag are all in the same plane. So this thrust will always be in the same direction as the velocity vector. V is the airspeed along the circular path. Let's say in the horizontal plane, the flight is turning like this. So this is the radius r of the turning, and v is the velocity along the circular path. Phi is the bank angle, r is the radius of the turn, and xi is the turning angle. How much it is turning is the xi, and xi dot is the rate of turn, which is angular velocity. So to find the equation of motion, if there is no acceleration along the flight path, then thrust, if you see, let's see, in the flight path, this is the aircraft, and this is the thrust force, and this is the drag. If there is no velocity also in this direction, if there is no acceleration, then F will equal to D. And if we resolve the force in the vertical direction, here you can see this is the angle phi, then L cos phi equal to W. In the horizontal direction, L sin phi will be equal to mv square upon r. M can be written as W by G. There are some kinematic relation also, V equal to R into xi dot radius into angular velocity. And rate of fuel consumption can be written as minus dW by dt equal to Cf. So, and here also we also define one load factor n equal to L by W. And if you see the equation here, if you divide these both equations, then you will get tan phi. You don't need to divide. If you divide this W here, then you will get L by W equal to 1 by cos phi, which is nothing but load factor. So this shows the relation between load factor and banking angle. If this phi is fixed, then n is also fixed. These are relations for finding turning rate and turning radius. Turning rate is xi dot equal to G by V tan phi, and tan phi can be written as under root n square minus 1. Similarly, turning radius r equal to V upon xi dot, and xi dot can be written from this equation. So now we will solve the problem. In the problem, we have to find load factor and turn radius, and we are given bank angle and velocity. So our bank angle is 30 degree and velocity v equal to 100 meter per second. we have to find the load factor N and turning radius R. So we have seen the relation load factor is 1 by cos phi. And what is cos phi? 1 by cos 30. Cos 30 is root 3 by 2. So it will be 2 by root 3. So here often B and C are not possible because load factor is not 2 by root 3. Now we have to find the turn radius. So for finding the turn radius, we can find using this equation. So what is R equal to B square upon G under root n square minus 1. We will put the values. 100 square. Value of G is 9.81 given in the problem. And is n square will be 4y. N square will be 4y3 minus 1. So if we put this value in the calculator, we will get 1765.5971, which will be 1.766 kilometer. So only option A gives the nearest value of this turn radius. So this is the correct answer. Thank you.